The roof of Palau Way in Barcelona has 20 chimneys. With the same general mythology, all of them have a pyramidal base on the bottom and a conical trunk finish at the top. Gaudi made them all different through the decorative treatment of the surface finish. In case of chimney number 13, the surface is divided into quadrilaterals, following an helical path. As the cone narrows, the quadrilaterals are reduced, keeping the proportions. This gradation, undoubtedly harmonious, demands all the helical trace keep its gradient constant. That's only possible if the helical path follows a logarithmic spiral projection. Besides, Gaudi reinforces the fragmentation of the surface, faceting the spiral with straight lines. This introduces discontinuity among the surfaces of quadrilaterals, which become hyperbolic paraboloid. Furthermore, Gaudi makes the 6 triangular faces of the bottom become flat, so the base of the cone becomes a regular hexagon. Finally, the geometric structure that rules the element corresponds to the subdivision of the initial cone by 12 logarithmic spirals. From an abstract digital thought, the processes should be as follows. First, draw a logarithmic spiral with extreme radii equal to the 2 bases of the truncated cone. Second, project the spiral into the surface of the cone. Third, make a symmetrical copy of the resultant spiral. And fourth, copy both 5 times at 60 degrees intervals. But this process is not applicable inside. To be able to construct it in worksite, the process must be rethought in terms of constructive geometry. As the name suggests, the logarithmic spiral is a curve that, in polar coordinate, is defined by a logarithmic expression that binds the radius length with the swept angle. But you can draw up the curves, somewhat approximately, with an error negligible in terms of construction, using 4 circumference arches. Alpha angle, through which drawing starts, depends on the 4th root between the ending radii. If this relationship is 1 to 4, as in this study case, the 4th root becomes a square root, and drawing at construction site becomes very easy. Let us now see the possible construction process of the element. When the inner truncated cone is already built, a string, with the size of the generatrix, is brought on the spiral previously drawn on the ground. Over this drawing, we can trace the radius corresponding to the 6 generatrices for the angles L, 60, 120, 180, 240, and the 100 degrees. The radii of the respective intersections with the spiral are now transported to the angle L position and projected on the string, which are marked with line. Returning the string to its respective positions on the cone, the corresponding points of subdivision can be marked. Again on the spiral, the process is repeated for intermediate generatrices. And taking this new string on the cone, you can complete the marking of the vertices of the quadrilateral network. At each cut point, nail tips relocate the position of each vertex to the final outer surface. These nail tips let tie strings to guide with mortar the construction of the 12 faceted spirals that define the subdivision in quadrilaterals and triangles. With line mortar and a guided ruler sliding on the trace segments, you define the paraboloids. Finally, Gaudi covers the surfaces with a broken tile mosaic as usual.